designed for the 300 kilonewton load which is given in a bracket. The first thing what we have to find is single shear. So you know the formula for strength of the bolt, that is shear strength. You have Fu divided by this factor of safety, that is gamma, into Ns and Anb. So the only property you have is the area component. So the net area will be 0.78 into pi d square by 4, where d is the diameter of the bolt. Shear capacity of the bolt 45.272 Newton. See here the term bolt is given, so you don't need to consider much. Why? Because you are designing a welded bracket. So this is the formula for finding single shear. So it is not an issue, you can use this formula and you will be getting design shear strength as 45.272 kilonewton. Next you have to find strength of bolt in bearing. Now how many number of bolts are required? We have to find for that what is the least of the force in shear strength as well as the bearing strength. So how to find these three components? What is the dia of bolt they have given? 20 mm dia bolt. Need diameter of the hole as what? 22. So D naught will be 22. E is known as eccentricity. You have to design. So the bolt edge and pitch distance will not be given. Number of bolts, everything you have to design, so that you can take minimum formula for edge distance. What is the minimum case for edge distance? Is 1.2, 1.5 into diameter of the holes. Yes. So what is your answer? 22 into 1.5 is 30. Then what is pitch? What is the minimum condition for pitch? 2.5 times diameter of the bolt. You use 2.5 into 20, 50. Here we have taken as pitch distance as 2.5 mm, which is 50, and edge distance it is considered as 55 mm. So your minimum distance is how much? 30, exactly. Then more than minimum distance you can take it. So here it is considered as 55 mm. Consider these three cases and tell me the least value. 55 divided by 3 into 22, 50 divided by 3 into 22 minus 0.25. FUB is bolt ultimate bearing capacity is 400, FU is 410. 52 divided by 3 into 22, so you have all the conditions. Are you getting KB as 0.5076? Yes, this is the least value, and if you find the bearing strength, it will be factor of safety is 1.25, you know that, and 2.5 is a constant. KB value, this is the least, 0.5076. What is the diameter of the bolt? 20 mm, and you have two thickness. One is the section thickness and another one is bracket. So what are the thicknesses? 10.6 and another thickness is 8 mm. So least is 8 mm and this is the ultimate bearing capacity of the plate. So what is your answer? 64.972 kilonewton. So what is the least of the force here? When comparing shear and bearing, this is your least of the strength. You have to take this and proceed the design. Yes. Now you have found out the strength of the bolt. Next thing is finding the moment. How to find the moment? If any force is acting, this is the axis, the column axis. If any force is acting outside the axis, how to find the moment? Force into this distance. So your force is 300 into 350. Now this force is in terms of kilonewton. It is being converted into Newton. So 300 into 1000, which will be in terms of Newton, into this 350. 105 into 10 power 6 thing is you have to find a number of bolts required. So you have this formula which n is known as number of bolt. 6 into m divided by 2 into Vp. 6 into this value 300 into 1000 into 350 which will be your moment divided by 2 into V which is the shear force. So that is 45,272. Everything is in terms of Newton here, and P is the pitch. Pitch is taken as 50. Now what is the answer? 11.79. See, around, let us round off this, around 12 bolts are required here. So if 12 bolts are required, so you can place it half, that is 6 numbers at one side and another 6 numbers at another side. So each row you require this number of bolts. Now next thing is how to find F1 and F2. Formula for F1 is normal shear strength divided by N. What is F2? P into E into R divided by summation of R square. Now you need R component. So what is P is force. Force is known to you, which is 300. What is E is known as eccentricity, which you know that eccentricity is how much? 350. 350 mm is the eccentricity. What is R? R is the radius. So that is why we are finding the radius here. And from the axis, you have to take extreme bolt. So what is the extreme bolt here? You have to take the radius of that. How to find the radius of this? You know the distance, which is 75, and the total height. How to find the height? See, each and every bolt has a distance of 50 mm. If you are taking this as a section, and between two bolts, totally 12 number of bolts are there. If you are locating it at the center, you will be having this place as 25. So rest of the bolt are there at the distance of 50 mm. So this is the pitch distance. And what is the edge distance? 55. So what do you mean by edge is the bolt between the end of the plate. So here ends the plate. So this distance is 55. And the opposite distance is also 55. Okay. What is the total distance of the flange? See, here you have a flange. What is the width of this flange? This is 250. If you subtract 55 and 55, so what will be your answer? 250 minus 55 minus 55. 140. So if you divide 140 into half, what will be your answer? 70. See, that is why you can see that this edge distance is 55, rest of the distance will be 70. So you know the width, which is 70, and the height as, what is the total height? If you add all the component, which will be 275. So if you need to find this radius, you have to square it. 70 square plus 275 square, you will be getting 283. So now this is your radius. Now how many bolts are here? 1, 2, 3, 4, 5, 6 number of bolts. You will be having 6 number of radius. That you can use, what is the formula? PE into R divided by summation of R square. Now since you have 6 number of bolt, you will be finding 6 number of radius. So how to find 6 number of radius? For the last bolt you have find the radius as 70 square plus 275 square. Now for this bolt, so what is the width here? 70 is the same, and what will be the height? 225. So 275 minus 50 will be the height of this bolt. Like that, if you are multiplying, you will be getting for the first bolt, which is 25, the height, which is 25 square. For the second bolt, you will be getting 75. 25 plus 50 is 75. And if you add 50 further, you will be getting 125. And from neutral axis to the next bolt is 175, 225 and 275. So these are all your vertical distance. The horizontal distance is the same for all the bolt. 1, 2, 3, 4, 5, 6. So for all the 6 bolt, you have 70 square. You can square 6 into 70. Now, how many bolts are like this? How many quadrant you have? 1, 2, 3, 4. Since you have 4 number of quadrants, you can multiply by this 4. So, you have totally 24 number of bolt here. Now, what is your answer for summation of R square? Answer will be 832,600 mm square. Do you have all the components? Can you find F1 and F2? You can find it by yourself. F1 is direct shear, which is 45272 divided by n is number of bolt. You divide by that. F2 force is 300, eccentricity is 350. Then R, radius is what? Radius of extreme bolt is 283 divided by summation of R square is this value. Now you can find your F1 and F2. So these are your components. You will be getting 35,786.5 Newton. Now you have to substitute F1 and F2 in your equation. So for that you need cos theta. Cos theta is what? Adjacent by hypotenuse. So adjacent is 70 and hypotenuse is 275. You divide that, you will be getting theta 0.24. Now for direct shear forces, force divided by number of bolt. How many bolts are here? 12 into 2, which is 24 number of bolt, and 300 into 1000, which is your force. Now F1 will be 12,500 Newton, and you can find the resultant force of extreme bolt. Now this is your formula. You substitute F1 square plus F2 square. Now this is your F1 and F2. You square this and rest of the components are known. Cos theta is 0.24668. F1, which is 12,500, F2 is 35,786 plus 2 into 12,500, 35,786 into 0.24668. You root this, you will be getting 40,714 Newton. Is this lesser than the strength of the connection? So what is your strength of the member? 45,000 around. So what is the force which is acting here? Which is 40,714. So design is okay. Now whatever bolt you have provided, which is sufficient, no need to revise. Here if the value is, say for example 49 or 50,000, what you have to do now? Redesign in the sense what you will do. Either you change the pitch distance or number of bolt, what you will do? You will increase the number of bolt. So for that what you will do? You have to reduce the pitch distance. Pitch distance 50 you have taken as minimum. Instead of 20 mm bolt and select the 22 mm bolt. Like that and redesign your structure. Hence the design is safe. We provide 24 number of M20 dia of bolt. Yes. Now let us go to last topic in bolt. Friction grip bolt. What are the criteria? So this is given in the class 10.4. You take down your code book and refer class 10.4. If in the given data they are indicating that we are using high strength friction grip bolt, if they are asking and if they are giving the terminology, you have to use this formula. So what is the formula here? Which is the design friction strength. How you can find this? You can divide it by nominal strength divided by the factor of safety, which is material safety, and you can find nominal frictional forces mu. What is mu? Coefficient of friction slip factor as specified in table 20. How you create friction, which is given in the table. See, friction depends on surface. If the surface is smooth, see, if you take mobile, your surface will be very smooth, and if you take the back cover or any cover, you will be having some rough side. How these are all created is by treating the material. Treating in the sense while manufacturing you have to do. After manufacturing, you cannot do that, and certain things you have to change. For making friction, you have to change this component. So how the surface are treated? If the surface are not treated, you have to take coefficient of friction as 0.2. If your surface is being treated or how it is being made, this in detail which is given here. In your problem, they will be specifying that how the surface is treated. When you are creating friction, that surface has to be given the terminology. Okay. Now, N is number of effective interface offering the frictional resistance. If you are providing with one bolt, see one bolt is there, and if three plates are provided, how many interface will be there? If you have three plates, two joints will be there. If you are only providing two plates with the bolt, you will be having one surface. So this is what they are indicating here. So how many interface will be there? If you have multiple number of joints and plates, you will be having higher friction. If number of plates are less, you will be having lesser friction. Now K, you have a constant called K factor. They have three classes. If fasteners in clearance hole, you have to take it as 1. So this will be given in the problem. And 0.85, the fastener is oversized. Fastener is the bolt. If the bolt is oversized, you can take 0.85 and 0.7 for fasteners in long slotted holes. Okay, these three cases will be given in the problem, and finally you have F. How to find F, which is the minimum bolt tension? How to find that? A and B. What is A and B? Net area of the bolt in thread. You have thread portion and shank portion, isn't it? So you have to take the net area of the bolt at the thread portion. And what is Fu, which is proof stress? You have to substitute Fu as what? 0.7 FUB. Okay, now let us take a problem and understand this concept. Determine the shear capacity of the bolt used in connecting two plates as shown in figure. See, the cross section is given here, a bolt is being used. Now they have given here as HSFG. What do you mean by this? High strength friction grip bolt is having the capacity of handling friction. Okay, now if you are using this kind of bolt, they have given the components here. What you have to find is slip resistance designated at service load. Next one is slip resistance is designated at ultimate load. So two loads you have to find here, which is for service load. Service load is Fy and ultimate load is Fu. How will you find the grade of the bolt, which is given as 8.8? Note that in the previous problem you had only 4.6 grade, isn't it? Now high strength bolt will be having much higher grade. What is your ultimate strength of bolt? Fu is how much? By this number you can find 800, 8 into 100, and you have 0.8 here. What is yield strength? 800 into 0.8, which is 640. Now you need to use Fy as what? 640 and Fu as 800. So this is the terminology here. The fasteners are in clearance holes. Can you find this difference? The three cases. Under which case your problem is given? Fasteners are in clearance holes. Have they given this content here? You have to use then KB as what? KB as 1 in this factor here, and they have given coefficient of friction as 0.3. They have not extended this component, which is mu factor. Mu they have directly given as what? 0.3. Now what are all the component which is unknown here? You know mu, what they have given? 0.3, and what is NE? Number of effective interface. So how many interface will be here? Two number of interface. So this is the one phase and another phase. Now this component is known to you, and what is KB? KB they have given as 1, which is there in fasteners are in clearance holes. Okay, now what is F? What is the formula? AN into F naught. So how to find F naught? 0.7 into FUB. The only one unknown component is this one. Now when you are using high strength friction grip bolt, you know that 8 into 100, which will be the FUB, and K1 is given as 1 here, which is fasteners are in clear holes, and coefficient of friction is also given as 0.3. Now the nominal shear capacity of the bolt you have to find. So this is your formula. You have to substitute all the components. Getting F naught as 0.7 FU A and B. Now what is your A and B is net bearing area. 0.7 FUB is 800 and net bearing area will be 0.7, 5 into 20 square divided by 4. Multiply all the component, you will be getting 1,37,225 Newton. Now your NE is 2 here since double cover butt joint are used. Now what will be your answer? 82,335 Newton. So first one, design capacity of one bolt if slip resistance is designed as service load. Now, so what is the capacity of this bolt? It can handle 82,335 Newton. So this is the capacity divided by 1.1 for the service load. So what is 1.1? Gamma material safety. If you have found this force gamma M, so you have to find this as material safety. So now take that tabular column. So you will be having at service load, which will be 1.1. You divide this, you will be getting 74,850 for single bolt. This one is for a single bolt. Now if you multiply, if you are using 6 number of bolt, then the capacity will be, see here how many bolts are here, 6 number of bolt in a plate. So now if you multiply 6 into this value, which is 74,850, what is your answer? Four lakh 49,099 Newton. Now this is the capacity of the bolt. Now the design capacity of one bolt in slip resistance for ultimate load. What is ultimate load is? You can divide it by 1.25. 65,868. Now you multiply this into 6. 65,868 into 6. 3,95,208 Newton. In case 1, the bearing strength of ultimate load should be checked. If it is low, then it will be governing the factor. So which is the lowest factor? This is 3 lakh, and what is the previous case? So this was 4,49,000. Now you have found the strength at ultimate bearing capacity and the yield, that is working load bearing capacity. Okay.